So this is a video on the linear programming worksheet number 3. So on this, Miss Shadow makes banana bread and zucchini bread to I think sell at a bazaar. A loaf of banana bread requires 2 cups flour and 2 eggs. A loaf of zucchini bread takes 3 cups flour and 1 egg. Miss Shadow has 12 cups flour and 8 eggs on hand. She makes $4 profit per loaf of banana bread and $5 profit per loaf of zucchini bread. To maximize profits, how many loaves of each type can she bake? Okay, so first off, I want to figure out what I should do to define my X and Y. And so I look at the question that they're asking. They want to know how many loaves of each type. So it's going to be loaf of banana bread and loaves of zucchini bread. Okay, so that is going to be my my definition. So I am going to get this here. Let X equal number of loaves of banana bread, and let Y equal number of loaves of zucchini bread. Okay, now objective function. Objective function is what you're trying to maximize or minimize, okay? So in this case, we are trying to maximize profit. So that's what my objective function is going to be. So what do I know about the profit? $4 for each loaf of banana bread, $5 for each loaf of nut bread. So for this, I am going to have for my objective function, let me make this a little bigger font. Okay, P equals, and I'm going to have 4x plus 5y. Okay, so that is going to be my objective function. Okay. Now, constraints. Constraints are restrictions, and we have some resources that we don't have tons of. So let's see. We have flour. So we need 2 cups flour and 3 cups flour. And we only have 12 cups flour. So I'm going to write an inequality or a constraint for that. We also have eggs. So we have 2 eggs here that we need. We need 1 egg here, but we only have 8 eggs total. So for my constraints, okay, one thing that I'm going to do is I'm going to have some constraints in terms of my X and Y. My X is going to be greater or equal to 0 because I can't have negative amounts of banana bread. Same with my Y. My Y is going to be greater than or equal to 0 because I can't have negative amounts of zucchini bread. And then I'm going to write one for flour. And so for flour, oops, not what I wanted. For flour, I know there's 2 cups flour for banana, 3 cups flour for zucchini. So 2 cups for banana, 3 cups for zucchini, and we only have 12 cups total. So it's going to be less than or equal to 12. And then if I want, I can clean this up. I can get this to be in Y form. So I get 3y is less than or equal to negative 2x plus 12. I could then divide everything by 3. So when I divide this by 3, it becomes y. When I divide this by 3, I get a negative 2/3. And when I divide this by 3, I'm going to get a 4. So I could write it in that form. And this is dealing with our flour. Then I'm going to have one on eggs. And so for our eggs, 2 eggs and 1 egg, so 2x plus 1y, and we only have 8 eggs total, so less than or equal to 8. I can again write this in y form, and this is going to be y is less than or equal to negative 2x plus 8. And this is for eggs. So these are going to be my constraints, okay? So I'm going to be graphing these on my graph. Now, first thing I'm going to do is I'm just going to label this number of, I'm just going to say banana. And over here, I'm going to say number of zucchini. And I'm going to come flip that. Okay. And because I have my x cannot be greater, has to be greater than or equal to 0, my y has to be greater than or equal to 0, I can have a, I'll have a vertical line here at x equals 0. I'll have a horizontal line here at y equals 0. And then I would be graphing everything above that. Now, in terms of my other restrictions on flour, I'm going to have negative 2/3 x plus 4. So I'm going to start at 4 and go down to over 3. So I am going to, let's see, this makes it a little fatter, sorry. Start at 4 and go down 2 over 3. So start at 4, go down 2 every 1, 2, 3, go down 2 every 1, 2, 3, and then I'm going to connect it with a line, and I would be shading underneath this. Now for my eggs, y is less than or equal to negative 2x plus 8. So for that one, let's say that I am starting up at 8, okay, for my y-intercept. And then I'm going down 2 every 1, down 2 every 1, down 2 every 1, down 2 every 1. And then I'm going to connect that with a line. And then I want to be beneath that line, beneath my orange line, above my horizontal line, to the right of my vertical line. And so that ends up being this section right here. And then for this, if I was following, I'm going to draw it temporarily in yellow. If I was following it, I would have a point here, a vertex here, okay, a vertex here, a vertex here, a vertex here, and then it comes back here. Okay, so that's my bounded region. So my vertices are going to be here at 0, 4, here at 3, 2, here at 4, 0, and here at 0, 0. So these are the vertices I'm going to plug into my objective function. And my objective function is, so 4x plus 5y. And so I'm going to be substituting in these vertices. So I have 0, 0. I have 4, 0. I have 3, 2. And I have 0, 4. And so 4 times 0 plus 5 times 0 is going to be 0. 4 times 4 plus 5 times 0 is going to be 16. 4 times 3 plus 5 times 2, 12 and 10 is 22. 4 times 0 plus 5 times 4 is 0 plus 20, which is 20. So my maximum is going to occur right here. My max will be $22 when we make 3 loaves of banana bread and 2 loaves of zucchini bread. So I'm going to write that answer. So maximum profit of $22 occurs when, let's see, and who was the character? Miss Shinshado. Occurs when Miss Shinsado makes 3 loaves of banana bread and 2 loaves of zucchini bread. Okay. Now, the next problem is very similar process. So the next problem, Ms. Van Sokoma grows and sells tomatoes and green beans. It costs $1 to grow bushels of tomatoes and takes 1 square yard of land. It costs $3 to grow a bushel of beans and it takes 6 square yards of land. Ms. Van Sokoma's budget is $15 and she has 24 square yards of land available. If she makes $6 profit on each bushel of tomatoes and $11 profit on each bushel of beans, how many bushels of each should she grow in order to maximize profits? So again, we want to kind of look and see, hey, what are we going to define our X and Y as? So we want to know how many bushels of each. So what are we talking about? Tomatoes and beans. So that's what my definition is going to be. Okay. So let X equal bushels of tomatoes and let Y equal bushels of green beans. Now my objective functions, what we're maximizing or minimizing. So in this case, for our objective function, we are trying to maximize profit. So it's gonna be profit again. So $6 profit, $11 profit. So our objective function is going to be profit is equal to 6x plus 11y. Then constraints, these are restrictions. So we will have some restrictions. We will have, let me start again. We will have restrictions such as we cannot have negative amounts of banana bread or nut bread, or sorry, this is green beans and tomatoes. We can't have negative amounts of tomatoes. So we're going to have X, let me make it a little bigger, is going to be less than or equal to 0. And same with our green beans. So we're going to have Y is going to be less than or equal to 0. Then we have some other constraints that we need to look at. So one of the constraints is it looks like we have some costs. It costs $1 to grow a bushel of tomatoes. It costs $3 to grow the green beans, but she only has $15. So she can't grow tons. Then we also have land, 1 square yard of land for the tomatoes, 6 square yards of land for the green beans, but we only have 24 square yards of land available. So let me write those. So if I'm dealing with the cost I know I'm going to have 1x plus 3y is less than or equal to less than or equal to 15. Now I could rewrite that. And so I could rewrite that as 3y is less, I was hoping that would copy and paste, but it doesn't. Okay. Is less than or equal to negative x plus 15. I can divide by 3. So when I divide this by 3, that 3 is gone. When I divide this by 3, I get a negative 1/3. When I divide this by 3, I get a 5. And this is dealing with our tomatoes. Then we're going to have one, I mean, not tomatoes, I apologize. This is cost. Then I'm going to write one dealing with square yards. So we have 1 square yard for the tomatoes. We need 6 square yards for the green beans. And we have a total of 24 square yards. So that's going to be less than or equal to 24. And then I can rewrite this. I can get it to be in y form. So that would be 6y is less than or equal to negative x plus 24. I can divide both of these by 6. So that is going to be just y. This is going to be a negative 1/6. When I divide this by 6, it ends up being 4. And this is for land. So now we're going to graph these. Okay, and so let me first just label the sides here. So this is going to be bushels of tomatoes. And this is going to be bushels of green beans. And then I'm going to flip that. Okay. So the very first thing I'm going to do is I am going to graph my x greater than or equal to 0. Then y is greater than or equal to 0. So I'd be shading above those. Then I am going to be graphing my negative 1/3 x plus 5. Okay, so I'm going to start at 5 and go down 1/3. So I'm going to start at 5 and go down. Okay, start at 5 and go down 1/3, down 1/3, down 1/3, down 1/3, down 1/3. And then I'm going to connect this with a line. And I'm going to be shading beneath this. Then I'm going to graph the other one, which is going to start at 4 and go down 1/6. Okay. So I'm going to start at 4 and go down 1/6. I'm going to start at 4 and go down 1/1, 2, 3, 4, 5, 6. 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 Let me just double check that. 1, 2, 3, 4, 5, 6. And then I'm going to draw this line. And so when I draw this line, I get this. And then I am going to shade where they all have in common. So let me just shade that. So that's going to be right here underneath those lines, but above the red. And I'm going to have some vertices. I have a vertex here. Let me change the color. Vertex here, 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 and here. And so my vertices are going to be 0, 0. This one is 0, 5. This one is 6, 4. No, 6, 3. 6, 3 if I count. And this one is going to be 15, 0. And then I'm going to put those into my objective function. So I'm going to put it into my objective function. Let me just, I'm going to just copy it and, oops, what am I doing? Copy, paste. Okay. Okay, so I'm just going to put it here. So that is my objective function. And let me fill it. Fill it with a color. Maybe I'll fill it with yellow. Okay. No, that's yellow writing. It's not what I want. Wow. Try it one more time. Fill, fill, fill. There. Okay. So I'm going to do these vertices into this. And so I'm going to have 0, 0, which is going to be 6 times 0 plus 11 times 0, which is 0. Let's see, 0, 5. And so that's going to be 6 times 0 plus 11 times 5, which is going to be 55. I'm going to do 6, 3. So it's going to be 6 times 6 plus 11 times 3. So that's going to be 36 and 33. So that'll be 69. Then I'm going to try 15, 0. So I'm going to go 6 times 15 plus 11 times 0. And 6 times 15 is going to be 90. And so my answer is going to be, so our maximum profit is going to be at 15, whoops, I had this one, at 15, 0, which is going to be $90 profit. So we're going to write our answer out. The maximum profit, I can't type today, profit of $90 occurs when you are, when you have actually 15 bushels of tomatoes and no bushels of green beans. And that's your answer.